So surface areas and volumes. Do you remember the formulas?
For some things, like for
Hmm.
the surface area of a cube, it's like
Hmm.
6s squared.
6s squared, yes. And I think these formulas are mentioned in a reference sheet at the
Reference
beginning
sheet.
of,
Mm.
yeah, at the beginning of the math section.
Yes.
Yes.
For rectangle,
So this is a cube.
for a rectangle, it's like 2s squared plus 4. Wait, there can be,
For
well,
not rectangle, you mean cuboid.
rectangular prism or
What?
a prism.
Rectangular prism.
Yes.
Yes. It's called rectangular prism. It's also called a cuboid.
Oh, okay.
So we have to do for. So see, this one is called a cube. This one is called a cuboid or rectangular prism. And then we have triangular prism. Okay, triangular prism looks like this. Imagine that you have a. Do you go to camping?
Uh, not often.
Okay. So the reason I'm asking is that, you know, when we go to camping, we set up
A tent,
camps or tents.
and it
So,
looks like a triangular prism.
yes, it is kind of like this. The tents. So, the tents are a perfect example for a triangular prism. Okay, so here we have a triangular prism. Then we have first let's do for these. Then we have a cylinder, a cone, and a sphere, but they involve circular bases. So in the next page we'll do the shapes, the objects with circular bases. Okay, so we have to do surface area and volume. And first let's talk about the surface area. And in surface area, Anika, there are two types of surface area. One is called lateral surface area, and then we have total surface area. So I'll denote lateral surface area by LSA and total surface area by TSA. Okay, and then we have volumes. Okay, so LSA, then TSA, and then volumes. Are you aware of the difference between lateral surface area and the total surface area?
So lateral surface area means without the basis, I think.
Yes,
So, and
without the
total
base.
surface area is everything.
Yes, exactly. So lateral surface area is without the bases. And so let's talk about cube. Cube means that all the surfaces are squares, right? So that means the lengths of all the sides will be same. So we assume that it is S. It's all the side lengths are S. So in this case, lateral surface area, if you remove the top and the bottom surface, so you have how many surfaces if you remove the top and bottom one? In a Yes, Anika?
So for lateral surface area, would that be 4
Yes,
squared?
yes, exactly. So you remove the top like the ceiling and the floor. So imagine in a room, you remove the ceiling and you remove the floor, so you have four walls left, right? So the lateral surface area will be 4s square, and the total surface area will be 6s square. And do you know the formula for volume of cube?
The volume of a cube is, well, isn't it just side cubed?
Yes, so side cube. Okay, now let's come to cuboid. Now in cuboid we have three different um dimensions. We have the length, we have the width, and we have the height, right? So this one, so if you look at the bottom surface, the floor of the room, imagine the cuboid as your room, right? Rooms, the rooms in which we are living, they are kind of cuboidal. So they have a floor. Let's say this is the length of the floor, this is the width of the floor, and this one is the height of the floor. Okay, so for lateral surface area, you remove the ceiling and you remove the floor, so you just have four walls: this wall, this wall, the back, the wall at the back, and the wall at the front, right?
Yes.
Okay, and we have to ignore the ceiling and the floor. So what will be the lateral surface area for a cuboid?
For a cuboid, wouldn't it just be, well, I think it would be, okay. Would it be height, wait, 2 times height times length plus 2 times width times length, or
Wait, give me one moment, Anika.
okay.
ग्लास में होगा, फ्रिज के अंदर ग्लास होगा, उसमें से ले लो. Yes, sorry about that. Yes, you
Would
was.
it,
Mm,
I think it would be 2 times
mm,
the height times length plus
mm,
2 times the height times width? Or is that
mm. 2 times height times width. Yes. Yes, you're absolutely correct. So we have removed the area of the top surface and the bottom surface, which will be 2 times the width times length. So in total surface area, we'll get the lateral, and always the total surface area can also be written as the lateral surface area plus the area of the bases. So the lateral surface area plus the area of the bases, which will be 2 times width times length. And this can be also written as, you factor out 2, so you get h times L plus h times W plus W times L. Volume is given by length times width times height. Yes?
yes?
Okay, now let's come to triangular prism. In triangular prism, um, if you talk about the lateral surface area, so you will remove the area of this, and also let's assume that this is the entrance gate. This is the gate from where you can enter inside the camp. So you remove the area of this gate and then the area of the bottom one, right? The one that's not visible. There will be one triangular surface at the back of this, right? And in triangular
Yes.
prism you will have this length with you, this length, the length of the tent, okay? And you will have these, like this one, which you can call it as the width, and you will also have the this height, perpendicular height.
Okay. So that's the height.
That's the height. Okay, and in triangular prism you You should only know about the volume. There is no as such formula for lateral surface area and total surface area. If you even if you have to find out the total surface area, you will just have to find out the area of this slant surface. For that you will need the length of this side as well. So you find out the area of this surface and then the surface on the other side, then area of this entrance gate and the one at the back and the bottom surface. So it depends on the question what they really want us to find out. Accordingly they will give you the values. But one thing that you should know is volume of triangular prism. Okay, volume of triangular prism. So Anika, for volume of triangular prism is given by, you find out
Um, the height. You have to find out the height.
no, height will be given to you. So height of this triangular,
Oh,
uh,
what do? I like multiply the length by the formula of area for a triangle?
yes, exactly. So you first find out the area of this triangle and then you multiply that by the length of the tent. Okay, so in this case if this triangle has height of h and the base is w, so the area of the triangle will be half w times height, and you multiply that by the height of the tent, which is L. Okay,
Okay.
so we'll only do volume for this. Now let's do the surfaces which have circular bases. The first one we'll take cylinder. There is cylinder, there are cones. We don't have a cone in this. There is spheres, and what else? Cylinder, sphere, cones. Okay,
Okay.
and hemispheres as well. Well, hemispheres are important. Wait, hemisphere. So first here I'll draw a cone. Okay, okay. Okay, Anika. So first we have a cylinder. A cylinder. First, we'll talk about lateral surface area. Lateral surface area, and then total surface area, and then finally volumes. Now in cylinder you will need two dimensions, Anika, the radius of the circular base and the height of the cylinder,
Okay.
right? So this
Yes.
is, so there are two circular bases, one on the top, one at the bottom, right? Both of them will have the same radius and this will be the height, right? So lateral surface area in this for cylinder will be the area of only the curved surface. Okay, the only the curved surface. And do you know what it's given by?
So the lateral surface, would it just be, would I just like pretend it's a rectangle, like for the lateral surface?
mm, Rectangle what?
Like, would I just multiply it by the height times the diameter?
Height times the circumference.
Oh, sorry. Yes, circumference. Because yeah, it's
Yes, so the circumference of the base is 2 pi r.
So yes, 2 pi r times the height.
Yes. Okay. And the total surface area will be, you add the,
So
yeah,
5.
go on.
Um, 2 pi r times the height plus
Mm-hmm.
2 times
Mm-hmm.
pi r squared.
Yes, exactly. And if you want, you can factor out 2 pi r, then you'll get
And just, okay,
h
height.
plus r. Yes.
Okay.
And the volume,
The volume, wouldn't that just be the pi r squared times the height?
yes, pi r square times the height. For volumes, what we also do is we take the area of the base and we multiply that by the height. So area of the base is pi r square and we multiply that by the height. Okay, so we have done cylinder. Now the cone. Now first let's do the surface area of cone.
Okay.
Lateral surface. So in the cone you will have, you need three dimensions. You need the radius of the base, which is this. Then there will be this height. This is called the perpendicular height, right?
Yes.
You'll need this height, which is h, and you will need this
Miss
slant height.
Brenda,
Yeah,
I'm so sorry. Is it okay if I just close the door really
yeah,
quickly?
sure.
Okay. Sorry, I think people just came over and they're creating lots of
It's
background
okay.
noise.
It's okay. Yes, so in cone, Anika, we need, yes, three dimensions: the radius of the base, the perpendicular height, and the slant height, right? And the lateral surface area of a cone is given by, do you know that?
Would it just be, well, would it be the lateral surface? Would that just be the height,
Which height?
for the cone?
Mm-hmm.
Would it be the height?
So in cone there are two heights,
Would it be
a
the height
perpendicular
times the,
height,
like the h times the diameter? Or is that wrong?
h times the diameter. No,
Oh,
it's
sorry, circumference.
no. In this case, it is pi r, pi times r times the slant height, pi r l.
Oh,
Okay. Okay.
okay.
And for total surface area, you do pi r l plus area of the base, which is pi r square. And again, you can factor out pi r and you'll have l plus r. Okay. And volume is area of the base multiplied by the height. But that's not the case with the cone. In cone, see, if you do pi r square and you multiply that by height, you'll get pi r square h, which will be same as the area of the cylinder, right? In
Right.
cone, there is one fact about cones that you should know. If you have, if just imagine you fill this cone with water, okay? You fill this up with water and you empty that water in the cylinder, okay? So
Okay.
you will be able to do it three times. Okay, you fill the cone with water, you empty it in the cylinder, you again fill the cone with water, you empty it in the cylinder, and you again fill the cone with water and you empty it into the cylinder. So you will be able to do it three times. Given that the radius and height of the cylinder and cone are same, okay, so that tells
Okay.
us that volume of a cone is one third of the volume of a cylinder, right?
Right.
So the volume of cone is simply one third of pi r square h. Okay. All right.
Okay.
And then we have sphere. So for sphere there's nothing called lateral surface area. So this is not applicable. total surface area is given by, and in sphere you need only one dimension, which is the radius. Okay,
Okay.
total surface area is given by 4 pi r square, and the volume of the sphere is given by 4 over 3 pi r cube. Okay, then you should also, yes, are you saying something?
Oh, no, I didn't say anything.
Okay, then we have hemisphere. Hemisphere is nothing but if you cut a sphere in half, so you'll get a hemisphere. Okay, this is like,
Okay.
and now in hemisphere you also get lateral surface area. Okay,
Okay.
so lateral surface area will be just the area of the curved surface. Remove the area of the top circular surface, so just the area of this surface, right? So can you
Yes.
guess what will be the area of this surface, the curved surface?
The surface will be half of it. I think half of it,
Half of
or
this, yes, half of this.
so that's 2 pi r squared.
2 pi r square, yes, 2 pi r square. And the total, so for total surface area you add the area of top circle. This is, the radius is r.
Okay.
So what will be the total surface area of hemisphere?
Okay, so if it's half, and then the total surface area. Will it, wait, so will it be 2 pi r squared plus r squared, pi r squared?
Yes,
Okay.
so that's going to be 3 pi r square. 2 pi r square plus pi r square. Okay, and the volume will be what? How much will be the
So
volume?
the volume will be
Half of the volume of the sphere.
so 1/2. So 4/6. So 2/3 pi r cubed.
Yes, 2/3 pi r cube. Okay, so that's it. These are all the objects. Okay, Anika, let's do some practice problems based on this. Okay, can you read this one?
Yes. Two identical rectangular prisms each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is km squared. If the prisms are glued together along a squared base, the resulting prism has a surface of the area of 92 over 47 k centimeters squared. What is the side length in cm of each square base?
Okay, what is the side length in centimeters of each square base? So, can you imagine an object which is a rectangular prism but it has a square base? It will be kind of like this. Just imagine that. Actually, let me try to get a rectangular prism with square base. You really need to imagine this object. Rectangular prism with square base. Yes, it's like this. I'll take a screenshot of this. We need two prisms like this. Okay, so we have this. I'll take a screenshot of this. Okay, so this is a rectangular prism, but their bases are square bases. Okay, and there are two of them. Okay, so there are two rectangular prisms and they have glued them along the square bases. Okay, so imagine the other one is glued to this one and they are identical, right? They are identical. Okay, oh my god, wait, okay, let's see. Can you imagine this figure?
Yes.
Something is not right. Okay, so I hope you can visualize what's happening here. This should be like this, yes. Okay, so there were two identical rectangular prisms which had square bases and they glued it along the square base. Okay, now what else
Okay.
they have told us? So now each have a height of 90 centimeters, so we'll do that, 90 centimeters. So this um, height of 90 centimeters, see, you have a square base. Don't think that this one is the height, because this is exactly what we have to find out. We have to find out uh, the side length in centimeters of each square base. We have to find out what is the side length of each square base. So this is what we have to find out. Side length of square base. Let's say this is x. Okay, this is what we have to find out. Okay, so height, that means they have given us this height. So this is 90 centimeters. Okay, this one is
Okay.
also 90, because there is no other dimension. You just have a width, which is the square base, and then you have the length. So this one they have given 90 centimeters, and they have given us that the base of each prism is a square and the surface area of each prism is k centimeter square. K centimeter square. Okay, so the square that you see, the square base, the
Okay.
area of this base is k centimeter square. What else have they given to us? They are saying uh, if the prisms are glued together along a square base, the resulting prism has a surface area of 92 over 47 times k centimeter square. So 92 over 47 times k centimeter square. This is the surface area of the resulting prism. The resulting, like this
Okay.
total shape. Okay, and you have to find out the side length, this x, the missing side. Okay, so you have three pieces of information, Anika, and in any question we will try to use all the information that's given to us. Okay, first information that's given to us is that uh, the area of this square is k centimeter square, right? So how will you use this information?
Um.
We have taken the side as x, right?
Yes.
Okay, so what will be the area of the square?
So
X
the area
square.
of the square is x squared. Or wait, is that
Hmm.
wrong?
No, that's right, x square. Okay, anyway, I think we don't need this x square. Now, first, let's try to use the information which said that the area of the resulting prism was how much? 92 over 47? Yeah, 92 over 47. 92 over 47 times k centimeter square. Let's try to find out the area of this entire prism, Anika. Okay?
Okay.
Okay. How can you find out the surface area of this total figure?
So the area of total of this figure. So we already have the area of the square.
See, they've also given us that base of each prism. Yeah, surface area of each prism is k centimeter square. Sorry, this is not the surface area of this one. That's my bad. Surface area of each prism is k centimeter square. So this prism that you see, like if you just take one prism, okay, if you take just one prism, the surface area of this prism is pi r square. I mean k centimeter square. So this one plus this, all the surfaces here, here. Surface area of one prism is k centimeter square. So what will be the surface area of two prisms, Anika, if you combine them?
The surface area of two prisms is 4HL plus HW plus WL? Or
No,
is
no,
that
no.
wrong?
We can do that, but that will only complicate the things.
Oh,
They have just given us the surface area of one prism, right? One of them. So what will be the surface area of two of them? Both of them. If you know the area of surface area of one is k, so what will be the area of two?
um, wait. So the area of 2K?
2k. Okay, so this is the area of the combined prism. So I can write this equal to 2k, but you need to subtract the surface area of these two surfaces which are glued together, which are not visible now. Right now they are just one prism, right? So this surface, the side surface of this prism is glued with the square surface of another prism, right? And that's not visible now. So you need to subtract the area of those two surfaces. Okay, one surface is coming from this prism, one surface will be coming from this prism. So what should I write here? You subtract the area of this surface.
Oh, so I have to subtract?
Yes, the surface which is hidden now.
Okay, so I'm subtracting one of the bases?
Two bases. One base is coming from this
Oh,
prism.
oh, because they're combined.
Yes.
Okay. Wait, so now it's going to be because one base is equal to. Wait, now I've confused myself. Would it be could it be 2HL plus 2HW plus.
No, there is no H and L in this question, HWL right now. What will be the area of this square? This square. You know that the
But won't that also
side
be X squared?
x square, yes, because we have assumed that the side of the square is x, and you have to subtract for two surfaces, so 2x square. Okay,
Okay.
is that right? Okay, now so we have this expression. Now we'll try to simplify this. So we have 92 over 47k equals 2k minus 2x square. We will try to simplify this, and we'll try to write k in terms of x square. Like here will be some number, k is equal to something times x square. So let's bring 2k on this side. So 92 over 47 times k minus 2k equals to minus 2x square. Can you simplify this, Anika, on the left hand side?
Left hand. Could it be k times 92 over 47 minus 2 is equal to negative 2x squared?
Wait, what? Can you repeat that?
Um, I was thinking you could take out k.
Oh, you want me to take out k? Okay.
Wait, is that right?
You can take out k, okay, so we'll get 92 over 47 minus 2, okay. Now simplify these, 92 over 47 minus 2, then you'll get a negative value. Take the LCM, 92 minus 94.
So negative.
Hmm.
So negative 2 over 47. So
Yeah,
1.
negative 2 over 47 times k is equal to negative 2x square. So can you tell me this relation final thing? K is equal to what times x square?
Huh?
Can you simplify this further?
Could I do? I don't know. Could I do like 2x squared minus 2 over 47k is equal to 0?
No, you have to bring it in this form. K is equal to something times x square. So you have to isolate k. How will you isolate k? Try to isolate k.
So like k. Then I have to multiply both sides by negative. Oh no, by 40 negative 47 over 2. Or
Yes.
so that means k is equal to 47.
Yes. K is equal to 47 x square. Okay? Is that right? So we have this relationship. Let me remove everything else. Okay. K is equal to 47x square. K is equal to 47x square. Now we have used two pieces of information. We used that weird fraction 92 over 47. We have also used the information that surface area of one prism is k, but we still haven't used this information that these lengths are 90. This length is 90. Let's go back to the question. So it says that glued together the resulting prism has a surface area of 92 over 47. What is the side length? Okay, how will you use this information, Anika, that the height is 90 centimeters? Now here try to find out by using that formula, the formula that we have, length times width times height. Okay, let's try to find out the um, form. Let's try to find out the surface area of one prism by our regular formula. Okay,
Oh, then
so this is x, this is x, 90, 90. So what will you have? Area of the bottom base,
okay, so area of the bottom base is 900 centimeters times x.
no, it's 90, not 900.
Oh, sorry, I read that wrong. 90 times
X,
x.
and you have a similar on top,
So it's 290 times x.
2 times 90, that will be 180, so I'll just write 180. Then you have the front and the back surface. So the front surface is this one, this one, right? What will be the area of this surface?
So plus, wait, it's back over there. Isn't that also 90 times?
Yes, yes, that will be also
Then
90.
wouldn't it be like
What?
360x?
Exactly. So 360x, I'll just write 360x. And then the area of this surface and this surface. Now we are talking about surface area of one prism. Okay, so that's why we are considering all the surface. So the left one and the right one will be how much? This one and this one.
Plus 2x squared?
Yes, 2x squared. And then they have given us that the surface area of one prism is k. That's they have given in the question. Okay, see this in the question, they have given that surface area of each prism is k centimeter square. So we can put it equal to k. So k is equal to 360x plus 2x square, and you also have the value of k, which is 47x square. So in place of this k, you can write 47x square. That is equal to 360x plus 2x square. So Anika, can you solve this quadratic equation now? This is a quadratic equation.
Okay. So it would be 45x squared minus 360x is equal to 0. Oh,
Okay. You could also do it smartly by putting it on Desmos.
oh, yeah, that's easier. So 45x squared minus 360x. So I'm getting 0 and 8.
0 and 8. And I think 8 is one of the answer choices. Yes, and option B is correct. Shown is a right circular cylinder with a radius r and height h. A second right circular cylinder, which is not shown, has a volume that is 392 times as large as the volume of the cylinder shown. Which of the following could represent the radius r in terms of r and height h in terms of h of the second cylinder? Okay, so here you have a second cylinder which is like really big. Okay,
Okay.
and its volume is the volume of this bigger, so the radius of the bigger one is capital R, and height of the bigger one is capital H, and its volume is 392 times the volume of this one. So volume of this one will be pi r square h, right?
Yes.
And volume of this one will be pi capital R square times capital H.
Yeah. Wait. So,
And this one is given as 392 times 392 times the volume of the smaller cylinder. Okay, Anika. So, what do you think? Like, what should you take as the radius and the capital H so that you get 392? You can check all the answer choices. If you take capital R as 8R and H as 7H, then you get 392.
okay, wait. So, okay. So, I, I think I'm confused.
What happened?
I don't know.
Okay, see, this one is the
Am I
volume of,
basically just plugging it in to
just,
the.
yes, just take the bigger cylinder. Take the first option. It says capital R is 8 times the small r, H is 7H. So plug in these values. 8 times smaller r, square it, and capital H is 7H. So just simplify this and see, will you get this expression 392 pi r square h? Can you simplify this?
Um, so I can divide it by.
No, you don't have to divide it, Anika.
So then, wait.
Simplify this and tell me what do you get. What is 8r square?
Oh, 64 r squared times pi times 7h. 64 times 7.
Do 64 times 7 and see, are you getting 392?
No.
No. So that cannot be option A. Take option B. Okay. In option B, capital R is small 8r. So 8r square and times 49h. Now see, are you getting 392?
It's
64.
64 times. No.
Still no. Okay, so this, it's not option B. Try option C.
So 49 times 8. So I think that gives me my answer.
Yes. So that means this is correct, and that means if the radius of the bigger cylinder is 7 times the radius of the smaller one, and if height of the bigger cylinder is 8 times the height of the smaller cylinder, then the volume will be 392 times the volume of the smaller cylinder. Okay.